Alright, let's take a look at question 17. In question 17, we're going to be assessed on how to find the inverse of exponential functions. Okay? Alright, so before we get started, let's go over the steps for finding inverses. Okay, so steps for finding inverses. It's just going to be a two-step process in this presentation. So what you want to do first, when it's presented in f of x notation, you're going to do a switch, okay? So remember, the inverse function does the reverse of what the original function does. So to reflect that reversal, we're going to do a switch, okay? We're going to switch x with the inverse of the output. The output, this is the output right here, okay? The output is f of x. So the inverse of the output is f inverse of x. So we're going to switch the in with the inverse of the output, and we're going to switch the output f of x with an input, which is x. Alright? After we carry out that switch, we are now going to proceed to solve for the inverse function, f inverse of x, and we'll be done. Okay? Alright, so another thing that you want to remember is a property of logarithm, the inverse property of logarithms. Okay? Inverse property of logs. There's just only one we're going to use here. Now, if you have log base b of b to the x, what's your answer going to be here? If the base of a log and the base of the exponent, that's the argument of your logarithmic function, if they are the same, guess what? They are inverses. They cancel each other out, and your final answer will be x. Okay? Alright, so this is one of the inverse properties of logarithm. So let's go ahead and take a look at this problem. We have the function f of x is equal to a to the x. Now we want to find the inverse, okay? The function that does the opposite of what this function does. So now what we're going to do is we're going to take the output and replace it with the input. F of x becomes x. A to the, now the input x becomes the inverse of the output. So instead of x, we're going to replace it with f to the negative 1 minus x, like that. Okay, now what we're going to do is proceed to solve for this f to the negative 1 of x. Okay, so f inverse of x is an exponent. So how do we power it down? What legal operation can we execute to bring this power down? Well, since we have an exponent base a, all we just simply have to do is use the inverse of exponent base a. The inverse of exponent base a is log base a. So what we're going to do is take the log base a of both sides of the equation. So log base a of x is equal to log base a of what? Log base a of a to the f inverse of x. Okay? Alright, so what happens here? On the right side, notice how it's similar to this property that we have illustrated here. If the base of the exponent and the base of the logarithm are identical, we have an inverse operation happening. So this and this a are inverses and take each other out. So we are left with log base a of x equals f inverse of x, which is our goal. Okay, we solve for f inverse of x. So using the reflexive property of equality, we can just write this as f inverse of x equals log base a of x. The answer to question number 17 is option number 3. Okay, so this is basically how we find the inverse of exponential functions. Now, how would you rate the level of difficulty of this problem on a scale from 1 to 10, 1 being extremely easy and 10 being extremely difficult, how would you rate the level of difficulty of this problem? Go ahead and place your rating in the comment section below and let us know why you gave this problem the rating that you gave it. Alrighty?